In this lecture, we describe the method of variation of parameters and do an example to illustrate how it works. So consider the differential equation of the form y double prime plus q of x y prime plus r of x y equals to g of x. So if y1 of x and y2 of x are a fundamental set of solution, for this equation, then a particular solution so let's call this one star. To the non-homogeneous differential equation is yp of x is given by negative y1 of x integral y2 of x multiplied by g of x divided by Wronskian of y1 to y2 dx plus y2 of x integral of y1 of x times g of x divided by Wronskian of y1 and y2 dx. Please note that in this formula, we are integrating this integrand, and then the answer we get to multiply by negative y1 of x, and here we are integrating this function. The answer we get to multiply by y2 of x. So the general solution is thus y of x equals to homogeneous solution plus the particular solution which is the same as c1 y1 of x plus c2 y2 of x, and then plus particular solution obtained from this formula. Now let's quickly describe the method by examples. Find a general solution to the following, just examples. Differential equations. This is example 1. Differential equation. So the question is 2y double prime plus 18y equals to 6 tan of 3x. So the first thing is to find the homogeneous solution. First, we obtain homogeneous solution. Now, the homogeneous solution is the solution to this differential equation. So let y equals to e raised power r x be the solution. So y prime y double prime. So substituting these values in this differential equation, we'll have 2 r squared e raised power rx plus 18 e raised power rx equals to 0. So which is 2 r squared plus 18 plus 9 e raised power rx equals to 0. So which implies r squared plus 9 equals to 0 is the auxiliary equation, since e raised power rx cannot be 0. And then we have divided through by 2, so that we have r squared plus 9 e raised power rx equals to 0. So this implies r equals to r squared equals to minus 9, which implies r equals to square root of minus 9 is plus or minus 3i. Or we can write it as 0 plus or minus 3i. So y of x is given by e raised power alpha x into c1 cosine of beta x plus c2 sine of beta x when r is alpha plus or minus beta I. This is by definition. So in our case, alpha is 0, beta is 3. So therefore, y of x is e raised power 0 times x, c1 cos of 3x plus c2 sine of 3x. E raised power 0 is 1, so y of x equals to c1 cos of 3x plus c2 sine of 3x. So, and remember that the general solution is usually the linear combination of y1 and y2. So this implies that y1 of x is cosine of 3x and y2 of x is sine of 3x. So this is what we are calling the complementary solution. This is a complementary solution of homogeneous solution. So what we call complementary solution is the same thing as calling it. So this YH, the same as writing YC. So H means homogeneous or complementary. So sometimes we use complementary or homogeneous, but they mean the same thing. Now, Wronskian of y1, y2, the determinant of cos 3x, sine 3x. Now, derivative of cos 3x by chain rule is negative 3 sine 3x. This one is 3 cosine of 3x, which will give us 3 cos squared 3x minus plus 3 sine squared 3x, which is the same as 3 into cos squared 3x plus sine squared 3x, which is just 3 times 1, which is 3. Now, by definition, particular solution is given by negative y1 of x, integral of y2 g of x over Wronskian of y1 and y2 dx plus y2 of x, integral of y1 of x times g of x, Wronskian of y1, y2 dx. So this will be given by yp equals to negative y1 is cosine of 3x, integral of y2 is sine of 3x times g of x. So remember, this is the differential equation you're solving. So in this equation, remember the general equation is y double prime plus q of x, y prime plus r of x, y equals to g of x. So which means that we need to rewrite this differential equation given so that the coefficient of y double prime is 1. So this is the same thing as y double prime plus 9y equals to 3 tan of 3x. So therefore, this is what defines our g of x. So g of x is 3 tan 3x. So here then, we will write this multiplied by 3 tan 3x divided by Wronskian is 3 dx plus y2 is sine of 3x, integral of y1 is cos of 3x times g of x is 3 tan 3x divided by 3 dx. So this is the same as yp, or particular solution, is negative cos 3x integral of, so 3 and 3 cancels out, so we have sine 3x tan 3x dx, because this 3 and 3 cancels out, plus sine of 3x. Remember, these are outside the integral sign. Don't pull in sine 3x and cos 3x inside the brackets. It's a product here. So integration is only affecting this part. Integral of cos 3x times tan 3x dx. So the work, so we know that tan 3x is the same as sine 3x over cos 3x. So for this first part, sine 3x times tan 3x is the same as sine 3x over cos 3x. So this will be the same as sine squared 3x over cos 3x. So yp of x will be negative cos 3x integral of sine squared 3x over cos 3x dx, while at this point cos 3x times sine 3x over cos 3x, the place for tan 3x. So this and this cancels out, so this will remain with plus sine 3x integral of sine 3x dx. Now, so let's call this one integral 1. Let's call this one integral 2, so that yp of x is the same as negative cos 3x times integral 1 plus sine 3x multiplied by integral 2. And so let's work out the value for integral 1, which is now we know that sine squared is the same as 1 minus cos squared. So this can be written as the integral of 1 minus cos squared 3x over cos of 3x dx. Then dividing each term by cos 3x is the same as integral 1 over cos is sec minus cos squared over cos will remain with cos. So that's what we have. And we know that integral of sec theta d theta is ln of sec theta plus tan theta. This by definition. And then integral of cos theta d theta is sine theta. Now, this part, if we let u to be 3x, then du equals to 3 dx, which means dx equals to du over 3. So this integral of sec 3x dx is the integral of sec u times du dx is the same as du over 3, which is a third integral of sec u du. And then this will give us a third ln of sec u plus tan u. So therefore, integral of sec 3x dx is nothing but a third ln of sec 3x plus tan 3x. And then the other one also for integral of cos 3x dx, we let u to be 3x, which means du is 3 dx, which means dx is du over 3. So integral of cos 3x dx will be the integral of cos u times du over 3, which is a third integral of cos of u du, which is a third sine u, which is a third sine of 3x. So therefore, I1 at the end of the day will be I1, which is the integral of sec as integral of sine squared 3x over cos 3x dx will be so this part for sec, we have gotten a third ln of sec 3x plus tan 3x, and then minus a third sine of 3x. Now I2 for the integral of sine 3x. Now let u to be 3x, which means du is 3 dx, which means dx equals to du over 3. So this will be the integral of sine u times du over 3, which is a third integral of sine of u du. Integrating sign, you get negative cos. So which will be negative a third cos of 3x. So at the final solution, yp, therefore yp of x is equals to negative cos 3x times the value of I1, which is, actually I can factor out a third, so I put over 3 into ln of sec 3x plus tan 3x, then minus sine 3x, and then plus sine 3x times I2. Sine 3x times I2, which is negative a third, plus 3x. So this will give us yp of x equals to negative cos 3x over 3 ln of sec 3x plus tan 3x minus will be plus cos 3x sine 3x divided by 3, and then this is minus cos 3x sine 3x divided by 3. And you see this cancels out. This term and this term cancels out. So which implies that particular solution is negative cos 3x over 3 multiplied by ln of sec 3x plus tan of 3x. So the general solution is y of x equals to complementary solution or homogeneous solution plus particular solution, which is y of x complementary solution of C1 cos 3x plus C2 sine 3x, and then this is minus cos 3x over 3 ln of sec 3x plus tan of 3x. So remember, when you are getting the integrals for a particular solution, we just are interested in the function itself. not the constants of integration, even if the integrals are indefinite. We don't add those constants of integration just the same way we do for the case of finding the integrating factor when you're solving first order linear differential equations. Another example, find the general solution to the equation x y double prime minus x plus 1 y prime plus y equals to x squared, given that y1 of x is e raised power x and y2 of x is x plus 1 are the set of fundamental solutions for the homogeneous differential equation. These were given because already the left-hand side, the coefficients of the derivatives, some of them are in terms of functions. So to make our work easier, because we have not dealt with that kind of problems, we provide the solutions. So solution, note that in this case, we are using the general formula y prime, y double prime plus q of x y prime plus r of xy equals to g of x. So this is the form in which our differential equation should be. So that will be the first step. In this equation, we divide everything by x. So we'll have y double prime minus 1 plus 1 over x, y prime plus 1 over x, y equals to, so remember this is square dividing by x, we get x. So this now is in the required form. So, which means that our g of x in this case will now be x. Now we get Wronskian of y1 and y2, this determinant e raised power x and x plus 1. Differentiating this, we get e raised power x, this will give us 1. So it should be e raised power x times 1 is e raised power x minus e raised power x into x plus 1. Which will give us e raised power x minus x e raised power x minus e raised power x. This simplifies to minus x e raised power x. Remember our y1 of x is given by e raised power x and y2 of x is given by x plus 1. Now, by definition, particular solution is given by negative y1 integral of y2 g over Wronskian of y1 and y2 dx plus y2 integral of y1 times g over Wronskian of y1 and y2 dx. So replacing these values in this formula, particular solution will be negative e raised power x integral of now y2 times g. Remember, g of x is given by x after rearranging this in standard form So x times y2 will have x plus 1. Wronskian is minus x e raised power x dx plus y2 is x plus 1. Integral of y1, which is e raised power x times g, which is x, over minus x e raised power x dx. So this x and x cancels out, so yp of x will be negative e raised power x integral of, actually this negative and negative can cancel out so that this sign of this one is just plus, because we have a minus here and there's a minus here. So x plus 1 over e raised power x dx minus, because of this negative sign, so x and x cancels out, x plus 1 integral of this and this also cancels out, so we have just dx. Now here we have e raised power x integral of now x e raised power negative x dx plus e raised power x integral of e raised power minus x. I'm just splitting this x plus 1 over e raised power x into x e raised power minus x plus e raised power minus x using loss of indices. Remember 1 over a power n is a power minus n. Dx minus x plus 1, integrating this one just gives us x. So here, using integration by parts, so let u to be x, and then dv to be e raised power negative x dx. So the u will be dx, and v, integrating this one, we get negative e raised power negative x. So uv will be negative x e raised power minus x minus v du. So this is plus now e raised power minus x dx, which is negative x e raised power minus x minus e raised power minus x. So this was helping us to find the solution to this part. So yp of x will be e raised power x into minus x e raised power minus x minus e raised power minus x plus e raised power x. This will give us negative e raised power minus x minus x squared minus x, opening the brackets here. So yp of x equals to negative x e raised power. So x times e raised power minus x minus e raised power x times e raised power minus x minus e raised power x e raised power minus x minus x squared minus x. So this will give us negative x minus 1 minus 1, and then minus x squared minus x. So which will give us yp of x equals to negative x squared. This and this will give us minus 2x. This and this will be minus 2. So this is the particular solution. Therefore, the general solution is y of x equal to the complementary solution plus particular solution, i.e. y of x, complementary is y1 C1 y1 of x plus C2 y2 of x, now plus particular solution. So therefore, this will be y of x equals to C1 e raised power x plus C2 x plus 1 minus x squared minus 2x minus 2. So this is the required solution. Thank you.